Example 1 is really classic. Finding the area of one petal is really common. Um, if you do it by hand, yes, absolutely. So sometimes they're calculator active and you're not doing it by hand and it's fine. And then sometimes it's calculator active and not calculator active. I don't remember what I just said. Doing it by hand is tedious. Doing it in the calculator is not so bad. So it kind of depends. Sometimes they don't even ask you to solve it. They just ask you to set it up. So you just have to figure out. And then with the setup, there's so many different ways they could do it, because they could say, they could do the whole interval, which is what I did, and then just do 1/3 of that. Or they could actually figure out, oh, I should do the negative pi6 to pi6, or they could do the like pi6 to 5, or they could do like the pi halves to 5 pi. They could do like any one of those intervals on a multiple choice problem, and you would have to recognize like, oh, that's going to find the petal also. So on a multiple choice problem, there's a lot of ways they could do it. Is the final answer the goal, or is just setting up the problem the goal? So there's a lot of different ways you could write these, so that you're not actually getting through that whole tedious process, but you're still showing understanding, if that makes sense. Yeah. So yeah, these can show up both on calculator active and inactive, because they can test you on these in a lot of ways. Yeah. Because these ones, you could if you wanted. The reason that I didn't really, well, it, I don't remember, I didn't make the video this year, but it looks like I did do that. Did I do this in the video? Yeah, so I did. Set it equal to 0.
Wait, you did that as when you were showing the second way you could solve it.
Yeah.
But if you were like going
So there's different ways. If you look at it and you say, oh, because it depends on how you do the problem. So if you look at it and you go, it's an odd number of petals, therefore I know the whole period is 0 to pi, and I don't feel like figuring out what one petal is, then I can find the entire area and just divide it by 3. That's one way of doing it. And if it's an FRQ problem, you can do it that way. If it's multiple choice and it's just the final answer, you can do it that way. If it's multiple choice and you see that the bounds are 0 to pi, you can do it that way. But if it's multiple choice and the bounds are not 0 to pi, you can't do it that way. So that's when you have to use the second method. That's when you have to go and set it equal to 0 and see where the petals are intersecting to see what the bounds are for each petal. And so that's what I was doing here, was finding the bounds for each petal. It would have looked very similar, it just wouldn't have had the 1/3 in front. So what I did here is I found the entire thing, all 3 petals together, and divided by 3. This was me, like, this was saying, okay, you can do the same thing, you can just find one petal at a time. I could do from pi6 to pi halves, I could do from pi halves to 5 pi 6, or I could do the negative version here, from negative pi 6 up to pi 6, and kind of get this right here. Yeah. No, because example 2 is a whole different shape. So that process would look exactly the same as this, it just wouldn't have the 1/3 in front. Yeah. So, but other than that, it'd be the same. Yeah. Yeah. So so that's the idea of, in number 1, I used the symmetry of the problem to solve it. I said there are 3 petals, all 3 of them are symmetric, so I'm just going to find the whole thing and divide it by 3. So I used the symmetry. This way, instead of using the symmetry, you are taking it, you're finding the interval for each individual petal, and then from there you're going through and you're actually solving the problem.
Like, could you have said 3 pi halves to pi halves just to find that petal on the right?
Well, so I do not do anything bigger than pi, because the domain is 0 to pi. So you're going to use this domain right here.
Oh, I see.
Yeah. So I would typically what I do is like I would find the first two and then I would just go with these pi 6 to pi halves. I would not do that because you could. Well, I guess you could.
Yeah, I think that was my question.
You probably could. I just honestly, because what we want to do is we want to say, how do I do this if I don't have a picture? You have a picture, so you're looking at it visually. What do we do if we don't have a picture? The safe way to do it without a picture is just to say, I set it equal to 0, I solved it, and I'm just going to use the first two. That's an easy thing we can all do. That's a good question. No, so I think that the pi 6 to pi halves is actually going to give you this. I think that that is actually what you're going to end up getting, but we can check it real quick. Does that make sense?
Yeah, it does. That's what I thought might happen, but I wasn't
Yeah.
sure.
Yeah. Let's double check. So we know the answer is 3 pi fourths, so let's double check and just make sure it gives us the right thing. So we're going to have 1/2 in front, and then we're going to do pi halves, and then we have 3 cos 3 theta squared, and we want that to equal 3 pi fourths. Yeah. So it's the same petal, it's just the petal with like a negative radius. I didn't because I was only doing one petal, not all of them. So this is when I had all three of them, I divided it by 3. This is just finding one petal. The interval is correct, it's just this petal instead of it showing up here. Yeah, because if you guys look at this, this is from 0 to 2 pi.
When you were saying for that right pedal, that I couldn't do the 3 pi halves, but I could do negative.
So typically, I would just not mess so much with interval with stuff that is out of the interval. I would just write down the ones that are there because what you're doing is you're just overcomplicating it, and you're doing it because you have a visual right now. You're trying to do it from the visual because that's more comfortable. I'm telling you that most cases you will not have a visual, which means we need to, so the visual was for the notes to kind of make it more understanding. We need more understandable. We need to throw the visual away because we will not have it. So this is how you do it by hand. You solve it. Take your first two. You're good. It's going to give you the answer. You can do your second two as well. Yeah, so we could do, like here, if we did pi halves.
Oh, you're saying that it doesn't matter if you did from like pi 6 to.
Yeah, it really doesn't matter, honestly, if you do any of them, but they are probably. Oh, I had the 3 pi from what I typed. They are probably going to want you to have it in that original domain just to show that you understand the domain of the problem, which is why I wouldn't risk going outside of the domain. Does that make sense? You're more likely to see stuff within that domain. Yeah. Yes.
So that's like 2 pedals.
Mm-hmm.
So it's like it's already divided rapidly.
So that would be 2 petals, then we would divide it by 2 to get 1 petal. Mm-hmm. Yeah. You can tell because one of them is interval, then from 5 to 13. And so 1 to 5 is the inner loop because it's smaller, and then 5 to 13 is the outer loop because it's bigger. And that's what makes it so you can tell. Yeah. Does that make sense? Yeah. So when we solved it, we only got the answers that were on 0 to 2 pi, right? So that's how we got the pi 6 and the 5 pi 6, is we solved the equation. We said, okay, sine theta equals 1/2 on the unit circle at 2 values. That's pi 6 and 5 pi 6. We knew that, okay? And then we said, this is supposed to have a period of 2 pi. So I still need it to have a period of 2 pi. I'm just, instead of starting at 0, I'm going to start the graphing at pi 6 because I want to start graphing either on the inner loop or the outer loop. I just want to start graphing on a loop instead of in the middle of the problem. So what I'm going to do now is I'm going to take 1/6 and I'm going to add 2 to it. So I'm going to add 12/6 to it. So 1/6 plus 12/6 is where we got the 13 from. So now I just have to see which one is further apart. So from 1 to 5 compared to 5 to 13. 1 to 5 is smaller. 5 to 13 is bigger. So 1 to 5 is the inner loop because the inner loop is small. 5 to 13 is the outer loop because the outer loop is big. So that's how you tell. You just compare the sizes. Yeah. They won't be the same. Yeah, then it just means that you didn't add 2 correctly. Yeah. Or it means that you misremembered the unit circle here. Yeah. Does that make sense? Okay. Yeah, it took me a while to figure out that's how it was working, and then I was like, oh my gosh, that's so easy. It was more like you really had to think through how these graphs were formed. And then once I realized that's how it was working, I was like, that's so much easier. Okay, so you can see it here too, like cos of 1/2 is you got the pi thirds and the 5 pi thirds, and then from pi thirds to get that full period of 2 pi, you just have to add 6 thirds. So that's where you get the 7. And then you compare 1 to 5 versus 5 to 7. The 1 to 5 is a bigger distance than 5 to 7 is. So that's why 1 to 5 is your outer loop, 5 to 7 is your inner loop, because 5 to 7 is smaller. No. Well, notice that's backwards from number 2. Yeah, those are backwards. So the outer loop and the inner loop don't necessarily happen in the same order. Like example 2 had the inner loop first, then the outer loop. Example 3 had the outer loop first, then the inner loop. So they don't necessarily have to happen in a specific order, but it is always true that the inner loop is smaller. You always have 3 too, right? Yeah, because we have the 2 answers we got from the unit circle, and then we still have to make sure that it has a period of 2 pi. So we have to find the third answer. The 2 answers you get when you solve the problem. We find the third answer because we have to make it so it's a period of 2 pi. So we finish the interval. For example 1, do that because we just needed the answers between 0 and pi, and we found all 3 of them. We could have found another answer, but it would have been past pi. But yeah, because if you notice, on this one, we only had enough to find 2 petals, right? From pi 6 to pi halves is 1 petal. From pi halves to 5 pi 6, that's a second petal. That's only enough for 2 petals, not for 3. Yeah, you're always going to have to do that because what we're doing is we're shifting the period over so that instead of starting wherever it started graphing, because these often start at instead of starting where the loop starts, they might start right here. And we're trying to say, I don't want you to start at a random spot. I want you to start where the loop starts so that I can find just the area of the loop. On example 2, it might start right here And that's not where I want it to start. That's not helpful to me. So what we're doing is we're just saying instead of starting there, I want you to start with the loop. But if I start with the loop, then I have to shift everything to start just a little bit later so that it graphs the entire thing. So that's what I'm doing is I'm saying if this shifts to the right pi 6, then that shifts to the right pi 6, and then the 2 pi has to shift to the right pi 6. So I'm just shifting everything a little bit over so I can still get the whole period in there, but I can get like exactly what I can see exactly what I want from it. Yeah, we don't have to do that with the rows curves as much because they're much easier to find the area of. So those are a little bit less tricky.
So like for some of these, you could just like use like actually let's say I have cardioid and I only wanted half, you could technically have to find the thing.
You wouldn't have to find the whole thing, you could find just half of it. Yeah.
Okay, and that's when you would think about what.
Yeah. Well, and with a cardioid, you don't even really have to think about what it looks like. You could just do 0 to pi. But then we'd be getting at, are you getting the right, are you getting the correct half to split it in half the right way? So I probably would be careful about that. Yeah. Okay. How do we feel about example 4? Finding the points of intersection. Good? Okay. Yeah. Okay. So let me look up the assignment for today and tell you what you're doing.